Welcome to CppChat, the CppCon edition, our annual chat with guests from the community. We have, well, I'll let John do the introductions. John?
Thank you, Phil. Immediately to my left is Andrei Alexandrescu. You all know him, he keynoted earlier. Further down is Sutter. You all know him. He's going to be giving a keynote tomorrow. And we're going to talk to them a little bit about those, as well as other things related to the conference and related to C++. But you have an announcement?
I do. So during the week, we had a raffle, a quiz at the JetBrains booth, and we said we were going to announce the winners in this morning's session. So I have some free...
I have a question for you, Phil, and that is, because I didn't do the quiz, what was this quiz about?
So we had 5 C++ questions, all of them particularly evil, as you can imagine, being C++, which is why only one person actually got all 5 questions right. So the point is that if you use one of the JetBrains tools, that will actually understand the code better than we do. So
in other words, the quiz would have gotten all, or the JetBrains code would have gotten all 5 right?
Yeah,
that's the point.
Exactly.
Right. Yeah. All right. So that's cool. So we have a couple of really exciting guests to have, and so I'm going to start right here with Andrei and ask you about the keynote. But before I ask you about the keynote, I want to talk to you about the workshop. You want to tell us a little bit about the workshop that you did pre-conference?
So for those of you who don't know, there's we've had this EEE workshop terminology proposed by John Lakes, Engage, Entertain, Educate, and it was inspired by actually one of John's co-workers at Bloomberg, Paul Williams, who after while being at a conference, he said, "Well, it would be great if there were a talk on how to give a talk." And so it's sort of a meta, and that came about because there's a lot of very good engineers, including in this room. By the way, I meant to introduce. I meant to say this as an introduction. Thank you for being here. It's like 8 a.m. I thought it was going to be like 3 people. We might as well be the only software engineers awake and dressed in this time zone right now. Okay. Thank you very much.
I'd like to point out for the non-video audience that there are thousands of people in this room.
Yes, thousands of people, and the billions and billions of online watchers are going to be later. Paul came with this idea. Bloomberg and many other companies and organizations, they have these excellent software engineers. They have a lot of good things to share, and they have they're not public speakers. Maybe they're first-time speakers, but maybe they're not very experienced. And it would be very nice to have some sort of a meta talk. So, of course, because I was there, I said I'll do it. And so I went to Bloomberg. I prepared material, and I went to Bloomberg. And I taught this workshop. It was half-a-day workshop on how to give a talk. And I went to Bloomberg in London and New York. They loved it. And then I forgot who came. I think it was Scott Myers who came later with the idea, let's do this for CppCon, because same reasons. There's a lot of great engineers, and delivering the material could be done more effective with the tools we can teach. So Scott, Kate, and I taught this last year. Scott since retired, and he said, you guys got to look for somebody else, and who else could be better than John Lakes as a speaker who can go through like 360 slides a minute. So we got John, and we taught this course, this workshop on Sunday, and it was terrific. We've had 23 people who are like just the right amount. We had like everybody spoke, and then we destroyed them. Everybody destroyed them. Now sit down like a facilitator, kind of on occasion. That's not good. Don't put your hands in your pocket or whatever, right? So it went very nice, and I believe we've got terrific feedback. And many of those people who've been in the workshop, they actually have given already or are about to give talks at this conference. And those who already did, I've been in a couple. They did notice a marked improvement in the delivery. So I would recommend this class to anyone who wants to be better at public speaking. I think there's a lot of subtleties to it, and a lot of things that you only learn from experience or by being in such a workshop. So you should come, let your coworkers know about it, and let's hope to have it next year as well.
I'm definitely going to hold you to that.
So I think actually one of the people who attended your course is actually co-hosting a podcast right now.
There you go.
I actually attended this year and last year. I've done it twice. It was so good. And I would highly recommend it to anyone that's considering doing that.
Did you get something out of the second one as well? It wasn't just
yeah.
for fun. It was you got.
Yeah, some things that I'd missed from the previous year and some things were new. And it's always good to be reminded as well.
And I haven't yet attended it, except that I was able to give a 5-minute talk, and I got destroyed. It was great. As last year, but I have heard from multiple people last year and this year already saying that they are speakers at the conference the same year, and that going to that has improved their talk that year, where they had given it better than they would have otherwise, including when they had given the talk before and people liked it, and now they saw, oh, I can do this and this and this better, and then put it into practice in the same conference. So thank you for helping the whole conference be better.
Yeah, I haven't really gotten a lot of feedback from this year, but I remember from last year, a particular speaker who spoke Monday, right after, he sent an email. He listed like 9 or 10 specific things that he did, and he said it gave him great confidence, and he was absolutely certain that it was a better performance. So yeah, I'm a big believer in the workshop, and we'll continue to do that.
John, you use an interesting word too, and I've heard the same from some other trainers, like I think you may know J.C. Van Winkle, who's also a longtime trainer from the Netherlands, and he first used this word explicitly a few years ago to me, and it really resonated with me, and you just used it again. It is a performance.
Oh,
giving a talk is a performance. Yeah. There's rehearsal, or at least there'd better be, and it's structured and it's prepared, it's scripted, but they're scripted or ad-libbed, but you have a plan, and you are performing while you're conveying education. So I like the EEE approach to it. That's a good summary of what's going on.
Yeah. Yeah, one of the things I think about is that as programmers, and I love this because, if we're writing something and there's a mistake in the middle, it's fine, we go into the middle and change it. You can't do that at a performance. You're playing a piece or acting something, and you're like, oh, there was a problem. I should have done that better. You can't just go back and redo that, right? But as programmers, we have that luxury. But giving a talk, it's a real-time performance, and rhythm and pacing and all these kinds of things are an important part of that. And you don't get to go back later and say, I should have made that comment. Let's take that out. Unless Phil is recording it, and then he can fix it all in post.
Once you say something, it's out there.
Yeah, right.
And it is just like a stage play. You get to fix it the next night.
That's right.
Like the next time you give it, and then you'll just basically make other mistakes, and you'll continue to be improving it.
Right.
I think a key turning point, at least for me, was to switch from a view, I'm giving my talk on X at the event Y, and I'm going to give my talk on X at another event Z, seeing it as the same talk repeated in different environments. I thought, no, this is event X, and it has its own thing, and it's its performance. I actually don't even copy the slides. I just take the slides and redo them for the new event. So I'm like, this is going to be event X, and this is going to be event Y, and they're going to turn out completely different depending on a variety of factors. So each talk you're giving is a performance in the same way that at scale, of course, Queen would not render their music the same at every concert. It would be like it's a live performance for real with real instruments, real like microphones and stuff. They would render their music live. Each concert is going to be a bit different, and that's what's great about Queen. They wouldn't say, "Oh yeah, we're playing our piece like that," and maybe we use like dubbing and stuff. No, never. So each performance is different, and you should regard it as its own entity as opposed to I'm giving my talk. And then, by the way, after a talk, you should be like half dead. I'm not kidding. So you should be drained. You should be like it. You can't do a mercenary job like, I gave my talk on X and then I went to another talk. And do you think your talk has changed anybody's life? If you consider it a pause in your day, if you consider, okay, so I've done this, I've eaten, and then I went to this other talk, and it was a good day. No, after a talk, you should be half dead in your hotel room. That's the rule.
So I've spoken with a lot of speakers right after they've given their talk, and I can tell you universally they all feel the same way, which is, well, it could have done better, it could have gone better, but but I'm really glad it's over. And that is a universal feeling. So, speaking of talks, let's talk about your keynote.
What about it?
Did you feel half dead afterwards?
I did, yes, definitely. I think it went well, and I think I got excellent, an excellent vibe from the crowd and the community. It's been a difficult talk to prepare because I wanted to convey. It's probably the largest range of topics I've covered, because I cover from like micro optimization all the way to this is why we can't have nice things. So it's a very wide range of topics in the same talk, and it's very difficult to navigate them all and still make sense of everything. Kind of keep an arc that carries the talk through. So I think it went well, and I think I hope it influences things, because as I said in the ending, I think if we all sit here and we're like, oh, these algorithms rotate, this is awesome, this is so good, we can't make progress. Progress comes when there's a free radical just bringing stirring things up and say, well, wait a second, with the tools we've got, consider Stepanov back in the day. He did try. There's this interview with him, and there's a lot of lore about Stepanov by now. It's kind of the sacred texts by Stepanov. So he gave this interview and he said, well, I was trying to implement STL in OOP, object-oriented programming. He tried with Ada. He tried with Lisp. He tried a number of languages and approaches, and virtuals came wrong, like a sore thumb. They would get kind of everywhere and not doing anything interesting to him. They were not addressing what he wanted to do at all. So he tried with virtuals and classes inheritance, these tools are not what I need. And similarly, for the kinds of things that I want to do, such as let's implement the sort of the 21st century sorting algorithm, or any algorithm. Let's implement the real deal, the real algorithm for the 21st century that's going to understand, adapt, and improve itself for all data shapes, types, and predicates that you have. So once you want to do that, you find that these tools are not good for you, just the same as virtuals were not good for Stepanov. So then you say, well, what are the tools that we need and want to have? And that's where the introspection bit comes in. So you want to be able to carry information and a good understanding from the user side who's calling, well, I want to sort these things. And you want to carry that information all the way to the sort algorithms, which is going to make many and important decisions, but many, this is the point, many important decisions about how to strategize the sorting process, depending on a variety of things. This is the thing, it's not like concepts, it's not one thing. It's a variety of things, the combination, the size of the data type, the cost of copying them, the cost of moving them, the cost of swapping them, the predicate complexity, how difficult is how many cycles is the predicate? Is it an expensive predicate? If it's very expensive, you don't even want to do unguarded, because the comparison is one extra comparison is gonna be very significant. So there's a bunch of decisions that the sort algorithm needs to make depending on characteristics of the inputs. And these characteristics need to be introspected. And this is the key to the next century. I think it's that this ability to endlessly customize software depending on the data types and the characteristics of the functions and the types being passed in. And by the way, there's one more thing I wanted to add. I need to apologize, to the public here and to the billions of people who are gonna watch this later. I did not date for 15 years. I'm out of the loop. Okay, so I made a mention to a dating application in my talk, and people are like, "That's not really appropriate. That's not really nice." And I thought it's an honorable thing to mention. So that shouldn't be bad to mention, because back in the day, there were a number of dating sites, and most of them were honorable. So I made this mention, and people are like, Andrei, that's I didn't like that. So apologies about that. I have no idea. I thought it's honorable. So again, I'm out of the loop. I don't know what I'm saying. So
Andrei discovers what Tinder is.
Yeah, that's right. That's right.
We understand. We understand. But what you just said,
Let me
though.
have one quick comment, and that is that keynote is already live on YouTube.
Yes.
And the title was Allegro.
I changed the titles.
Oh, you changed the title.
Right. So right now, speed is in the mind of people.
Speed is in the mind of people.
Right.
All right. So that's what they should look for.
Which, of
Okay.
course, got misinterpreted as well.
Oh, that never even occurred to me. All right. Yes. All right. Back to what I was originally going to say, the actual technical point you were making. So a very wise person back last December, I think it was, at Meeting C++, gave a keynote on the next big thing. Do you remember who that was?
That was me.
Yeah, that was you. And you were making the same point you're making now, which is that reflection, you call it introspection. There are many kind of synonyms for it, but in particular, the ability to reflect on your source code and to inject or generate. Sometimes people use the word reflection to mean just the one direction, but you want both of them. You made the point is key to the next generation of software languages. I totally agree. That's what Metaclasses, which has been pushing reflection and generation with a use case. Here's what you can do with them. One thing of many that you can do with them for a number of years now. There is nothing more important to our next several decades of software engineering. It is going to affect not just the way we write code, as you've already found in D and in C++, but it's going to affect the way we design programming languages. Because the programming languages that we design that are come new in the next 10, 20 years are, if the popular ones, are going to heavily leverage that, and it is going to affect the kind of language they are, and also the divide as to where the language ends and the library begins. We can start moving back more toward building libraries because we have more expressive languages. And I think that's a really important thing. I'm just curious, for those of you who are here in the studio audience, how many of you have used or know about or are excited by if-const-expr? Oh, lots of hands. Okay. I have news for you. If-const-expr is absolutely great. It lets you customize algorithms. You don't write overloads. You say if-const-expr implementation 1, else fallback implementation, and even more things besides that. Ain't it wonderful? Do you like if-const-expr? Yeah. You know where it came from? From D, static if. And it's similar to that. There are differences. But I have the mic and say there are differences, but to me, and we've talked about this lately, to me, both if-const-expr and d-static if are going to be obsoleted. They're just 0.1 steps toward, they're very special purpose, narrow features that are subsumed by a more general model of introspection, being able to reflect and generate code. Turns out when you have that, you're not going to need either if-const-expr or static if, because they're subsumed by the more general thing. So it's great that we have that language feature for now, but we already have its granddaddy coming to replace it. And that's a very exciting thing. That's not going to be happening in the next few months, but in the next few years and influencing the next few decades of programming language design, including in C++, I think is an extremely exciting thing. And this does apply to C++. This isn't just about, some future new other languages will do something differently and we don't get the new toys. We already have if-const-expr. We are going to get reflection and generation. And these are very important things that we will get in our favorite language. But so will broadly the industry, I'm convinced. And I think that's a very important thing. It is of the same magnitude as the OO revolution and the still ongoing move to concurrency and parallelism. In fact, it will help with some of those same things.
Thank you. Just for context, you should know that. So I'm gonna raise some sting here, okay? So this is like it's gonna turn down. The morning is gonna turn down. So just to give some context, first Phil was very kind to invite me alone for this interview, and he pointed me to the last year's interview with Herb, which I watched, very well done. But I thought I'm too much plutonium, so I need a bit of graphite to moderate. Right, so I thought I'd be too intense, so I would need Herb, who's like I don't think I know personally any one person who is such a wonderful mix of technical person and people person that Herb is. And actually I said, oh, you should bring Herb, my friend Herb, to the interview. And then I thought I sent the email to Phil, and then I thought, wait a second, does Herb consider me his friend? Because Herb is like, because really, Herb is the Keanu Reeves of C++. He's everybody's friend. Like people see Herb like on the street in Seattle, is like, oh yeah, he's my friend Herb. Because
I'm taking this mic away from you. This is getting embarrassing.
Some people have even started dressing like him.
It's actually funny. More than one person at this conference has already told me, because they were wearing a Hawaiian shirt, somebody came up to them and said, "Hello, Herb." Oh, that's really good. Notice that I don't always wear Hawaiian shirts. Often on camera, it's easy to thread a microphone through, which makes it convenient. But thank you for inviting me along on your CPP chat. I'm not giving this back to you yet.
So you seem to have a lot of insight into where C++ is going. You should give a talk on that.
Oh yeah, there'll be something on Friday.
Okay, what can you tease us about? I don't want you to give the outline or the.
Well, the abstract's already published,
Well, sure.
The large part of it, so about 75% of the talk will be an incrementally updated version of a talk I gave at ACCU about my proposal 709 on lightweight exception handling. Mm-hmm. It'll talk about motivation, the why, as well as the what and the how. But I'll have updates there as to what's been happening since ACCU, including at the committee meeting in Cologne, where it reached the evolution working group proper for the first time, which is like where you really get the design, the rubber hits the road design feedback. And it was just a first view. It's a multi-year process, but I'll share updates to that. But also I'm adding a part where I'll talk about RTTI. Because there are basically the only two features that every C++ compiler has a switch to turn off. Tells you something. Like people are voting with their feet. They already have voted with their feet. They're gone. They're not even in the room in the building anymore. It's like look, those compiler switches they left. That's the evidence that they were once here, but now we have a fractured community. So I'll also just start off with just some all-up view of what really could be, or perhaps should be, C++'s evolution priorities. But again, to be clear, I do chair the committee, but I'm not speaking in that capacity. I'm just speaking as my personal opinion. I have to make that clear all the time because people often assume I speak for the committee, and I'm not doing that in this keynote. Where I report committee results, I'll try to be very clear about, okay, this is what the committee thinks and here are the straw polls, but this is my own personal view, which is no better or worse than anybody else's in the committee, and it's one of many proposals in progress in the committee.
Anyone with any interaction in the committee knows that it does not think with a single mind, and no one person is speaking for it.
Many people don't have that interaction in committee, and they do think that there's a monolith, or there's a spokesperson, but we don't have a Moses or an Aaron. So
everyone in the committee just does whatever Herb tells them to do, right? There's no independent thinking. It's just their marching orders, right?
What a beautiful world that would be.
So, longtime listeners to this podcast, I've expressed my opinion about this, what you referred to as lightweight exceptions before. I think that it is just an incredibly exciting feature, and the reason is for exactly what the way you've said it. It's going to bring the community together. I mean, we now have this situation where for a huge number of use cases, the current exceptions is perfectly fine. It's a great way of handling errors and all that. But there's a few situations where it's just a little bit too heavyweight. And so because some people legitimately have to opt out, anyone who wants to write a library that can be used by everyone has to say, well, the vast majority of my people my users should be using this kind of error message or error handling. But there are some people who can't. And so I'm forced in a situation. Do I follow standard practice and use exceptions, or do I allow something else? And it divides the community. There's like, and it even, I think there's a lot of fear and uncertainty about exceptions. So people who really should be using them also feel like, well, no, I'm part of this little group over here.
And one thing I found is that I was really happy to find, and you'll see in the straw polls, that in general, the committee, including the part that I thought might be the most resistant to change, generally agrees that this is a problem worth solving. It's not unanimously, but it is very important when you've been working on a language for quite a while, and you're aware of what it was intended to do and the vision. It is very important to be able to take the reality check of it's not working out the way I thought. And it's not just people doing it wrong. Oh, well, you're just doing it wrong. Try harder. Or, oh, well, the implementers didn't try hard enough. Like they should just make the implementations more efficient. It's important, and it's sometimes difficult to get over that because you have a beautiful feature. The thing that helps with that, I think, is recognizing that if you have a beautiful feature, sometimes you don't actually have to change the user interface very much. Just say, by the way, there's a simpler way to implement it. And if we can do that with very minimal change to the user interface, admits a better implementation, then we still have that same try-catch that we love that separates error handling from regular control flow, automatic propagation, all those beautiful things.
Allows for brilliant code.
But without the parts that are holding us back from using that. And you have a talk later today with a horrible, horrible title. I say that because it's beautiful and I wish I'd thought of it. It is, and this is hard. This is hard to say clearly. It is the dawn of a new era.
For those of you in the room, that's at 2 o'clock. And just want to point out, it's very complementary to the material that Herb's going to present. It sort of follows on more deeply to the supporting proposals, but also a bit of the historical context, because I trace it back to some ideas that Andrei actually introduced to the community some years ago. And I'll let you see the talk to find out what that is.
So one of the things that that you touch on as part of your proposal, it's not the heart of it, it's kind of the follow-on, is something that I had a discussion with, I think they would probably rather I not actually mention any names here, but there were a couple people who were very well respected in the C++ community now working on Swift. And one of the things that they said was the assumption from the beginning with Swift was that running out of memory was not recoverable. Because in practice, and I'm not an operating system, but someone told me that in Linux, if the system can't, when you malloc memory, if it's completely out, there's no swap space, you're completely out of memory, it will still not return a failure. It will return an address that when you try to access it is a failure. And essentially that means that if you're in that kind of environment, you really can't recover. If you're out of memory, you're toast. And so that was the assumption they went with Swift. It's an underlying assumption. So there are other kinds of errors obviously we recover from, but if you're out of memory, we assume you can't recover. You've driven your machine completely into the ground and it's an unrecoverable situation. And that's so simplified. And I could read it in their faces, although they were both saying it at the same time. It's like, that made just everything is easier to deal with. It's such a wonderful assumption to be able to make. But in C++, we've always said, well, what if you were in this, what if you weren't in that? So what if you were in a low memory situation where you could run out of memory and you need to somehow be able to recover from that, at least it's theoretically possible. I don't know how many users are in that. I don't know what kind of environment that is. But supporting those users, C++ is about the language for everything, right? You can do low-level stuff, you can do big stuff. So it's tough.
I remember in the Swift documentation page that talks about this, and I remember the phrase, I think verbatim, is C++ aspires to handle out of memory.
Right.
Which is true.
Which is true.
And I remember talking with the person who wrote that page, who isn't one of the former C++ers, the main ones like Dave Abrahams and Doug Greger and those smart folks who've been doing a great job working on the Swift design and implementation as well. We miss them. You're welcome back anytime. But they're breaking new ground there, which is always interesting. It floats the entire programming language community. But one of the things that it's important, I think, to be And you see this happening in Swift, you see it happening in Go, you see it happening in Rust, and you see it happening in C++, is that there are like 2 or 3 specific points on what do we do about exceptions out of memory and how to handle whether at the call site of an exception you can see it in your source code or not, where the whole world is gradually converging. It's a slow motion thing, but it's where they're gradually converging. In particular, so for out of memory, for example, the systems that take the view that no, out of memory is not recoverable are seeing pressure from their developers to say, but what do we do sometimes if it is? Because in C++, out of memory, or a allocation failure is the better general way to say it, because not every allocation failure is out of memory. So sometimes we say as a shorthand, but the intent is to talk about allocation failure. Many allocation failures are perfectly recoverable. If I'm asking for a buffer of 1 million and I don't get it, that does not mean I can't continue executing normal code anymore. It doesn't mean I've exhausted the abstract machine. I may be able to recover from that by asking for a buffer half the size and fall back. So some of those are true. But if I can't allocate an int, like if new int, honest to goodness, fails, I'm in serious trouble. I probably can't even call my destructors to unwind, to report the error. Never mind, there's just probably no point. So I have some interesting things to report about that tomorrow on the slides that I'm continuing to create and tweak, which will stop happening about 3 minutes before the talk. But these ones already exist, and I'm talking about the reaction in Cologne. But we can talk more about exceptions then, but I think it's interesting that as far as error handling goes, which is probably the most fundamental thing in any programming language. You can learn a lot about any programming language by looking at how they handle errors. You'll learn a lot in your first 15 minutes looking at any new programming language. And how they're converging. So one of the other parts of the proposal, for example, is try expressions, which are totally unreasonable in C++ today because almost everything can throw, and it would just be littering to put try on every possible statement. Right? That would not be worthwhile. If we could someday make most functions not throw, then it would be worthwhile. But Swift did that. They have try expressions, basically, which I'm also proposing as optional for now, but we could maybe make them mandatory someday in the future when most things don't throw, if we ever get to that point. But Go is going through the same thing. So Go right now has no way to automatically propagate. So they have sort of the result of T kind of model, where they basically, you're in this world of if error, return error, if error, return error, and you're doing this all over the place. And so they're also exploring the idea of basically a try expression. They don't call it, the proposal there last time I looked wasn't try, I think it was check or something like that. There was another word, I've forgotten what it is exactly. But it's basically the same thing, which basically means, please propagate this automatically for me. And it ends up in exactly the same place as Swift has ended up, and as where I'm proposing ending up for this, where you have a keyword that says this might throw, and you get automatic propagation, and you get a visible trail through your source code. You can see where the possible exceptional points are, so you can reason about your control flow paths through your code. And it's interesting because they each came at it from a different direction. Some already had the visible error propagation, but they wanted it to be automatic. Some already had the automatic error propagation, but wanted it to be visible. That's us. So it's interesting to see that convergence. And that's one example with try expressions, out-of-memory handling, and that exceptions are a really good model but should be thrown by value. Multiple major languages are doing all three of those things, and they're all moving in that general direction, which is a good sign, I think, for programming languages in general.
Well, all programming languages are ultimately trying to solve the same problem. They're just accepting different trade-offs for the different approaches, so it doesn't surprise that they're going to get to the same place in some way.
I'll know that the microphone was taken away from me and the discussion drifted. The topic was changed as soon as I said I'm too intense. I would like, though, to monomaniacally return to the same topic, which was introspection and such. And I have to say I very strongly disagree with Herb on a number of tactical issues. Who here uses the if statement? Who believes the if statement is niche? No, leave the hand down, please. Who here would use, instead of if, a construct that requires you to use 2 more keywords and add an extra scope? But it's more general. Leave the hand down. There should be unanimity here. So my point here being, static if is the unit of introspection, as the same very way if is the unit of control flow. You wouldn't write code without if. You wouldn't write code like it's a requirement for Turing completeness. You gotta have some way. So if is like there's no 5 lines of code without an if, right? So there should not be a movement to replace if with a much more difficult construct that is that somebody creates an argument that it's a bit more general. There should not be this. It doesn't happen because it would be stupid, right? It doesn't happen because it would not deserve to happen, right? By the same very token, static if is the unit of introspection-based design. It is the fundamental building block. My code has a static if with the same frequency as if. There's no code I can look at without some static if in my eyes. Give me a second. You've had a microphone. So this whole notion, and also I've been in Andrew Sutton's talks about introspection and stuff, is like they had a contest, who can do this in the most complicated way, and he won. It's too damn complicated. Like template if now? What's template 4? What was that? Template 4? All that nonsense. All of these complicated ways of doing something very simple. You do want to have the basic blocks of introspection the same very way you have the basic blocks of control flow. You need to have a simple way to test something and do something. So that'll be static if, not if const export. That's really poorly copied. It introduces that scope. It's just not useful. So you gotta have the basic unit of introspection, which is static if. If this is true, then insert this code. Otherwise, insert that other code if you wish. And that there's no ifs and buts about it. And I know C++ leaders are smart people. I know they want the best for the larger community, right? So they gotta do this. In my mind, there's no negotiation here that's even possible. Oh yeah, we don't want if in C++. We gotta replace it with a much more complicated construct. Who would vote for that? Nobody. And then you gotta have a simple way to iterate things during compilation and insert code. Again, there should be no scope created. And just insert that code. These are the basic building blocks. And then yes, we have escape into static mode, do a lot of crazy stuff, and then escape back, generate code, inject, we have the injection thing and all the good things. But these are these are very nice to have, but you gotta have the basic blocks. You wouldn't design a language without if. You wouldn't design an introspection-based language without static if. So this is like this is why I wanted you in this room, so you understand this.
We've been talking about this for the past month, so I think I fully understand where you're coming from. I hope that you understand that I actually mostly agree with you, and that I think that you actually do need simple generality, not one narrow feature.
You want a number of them, but you want a number of features, but you wouldn't want the to not have the basics.
Right, and so I think that, first of all, I think that the people in this room I expect at least some might be bemused because they don't have the context to understand what you're probably talking about, but I do, and I do appreciate that the talks that Andrew has given already today, he has disclaimed, are showing a placeholder syntax. He has called out places where there's like 7 reification operators, and there probably ought to be only one. So I think we're actually in violent agreement about many of these things. And some of them are in the context of, okay, how do we add some of these features to an existing complex language? So that's partly a constraint. But I think there are also other options that we can explore. But I'll also understand that a lot of what's going on now in compile time introspection, in generation, are demonstrating the possibilities, demonstrating what is possible in the context of C++, but they are very early, Andrew disclaims that as well, and that they are subject to refinement, and as we discover what they are and what the keys are, there will be a cleanup phase, and I promised you that. Having said that, it is not a reasonable argument to say that all you need is if and for. No. Because I have heard a very smart person say, at least to me privately, that, well, really, you only need compile time if and compile time for loops. Those are the only ones, so static if and static for each, like in D. You don't need anything else because, like, you don't need static switch, you don't need static other things.
They're nice to have, but my first question to you would be, with these extra complicated features you have, how do I do static if? And if it's anything more difficult than writing a runtime if, then we've lost.
I understand. And so just to be clear, in D, what is called static if is what in the current reflection and generation proposals for C++ is called const eval if. I'll spot you a few characters. It's the same number of words, but it's more general. But it's more general because it's not const expr if. It's not a const eval if. It is const eval anything, which means it's a general form of const eval any code, which means I get switch, I get for, I get all the other things, I get the whole language, not just if.
But then do I need to write some other operator to inject code by hand, or it just comes?
Well, then it's very explicit. Here's const eval where you start executing this code at compile time. And in there, if you want to do injection, yes, you write one glyph or arrow for injection. And that is more general than what you have. And I think that's probably as deep as we can go without a whiteboard. Don't point out that there's a whiteboard over there.
Well, it's also as far as we can go because we are out of time.
We're just getting started.
So, part 2 of this same talk will happen next year at CppCon. Our tradition to end the show is to wish everyone safe coding. So for the thousands of people in this room and the billions of people who are watching online, from all of us, we wish you a safe coding.
Thank you very much.
Safe coding.